Good afternoon. This is Jeffrey Hammond from Forrester, and I'm very happy today to be talking about some of the things that you need to think about when you would go to implement an enterprise scale API and some of the management associated with that. And what I'd really like you to think about today is the idea that data, the data that you create, the data that you own, the data that your applications possess, is really a hidden gem for your organization. It's the value that you can provide access to on the web that creates an Intel Inside type of effect. And the value that data has is something that it really is valuable to unlock through APIs that you might provide to it.
And let me add, Jeremy, this is Scott Morrison, CTO of Layer 7 Technologies, and I'm going to be doing this webinar with Jeremy. And I think you just made an excellent point, actually, because data these days is power. If you control the data, whether you're, let's say, Facebook or Salesforce.com or some giant repository of data like this, if you control the data and the way in and out of that data, you actually control a tremendous amount of useful information. It's a powerful position. And so a lot of what we're going to talk about in this webinar will be exactly how you can manage that effectively, how you can begin to monetize that data through APIs.
Thanks, Scott. I appreciate that. Now, I'm not being very original here because I have to claim that I have to confess that I've taken this idea from original sources, and at least it's a very good original source. If you go back to kind of the formation of the thought around Web 2.0, O'Reilly really put it together in a great essay, and geez, I think we're almost back in the 2005 time frame. But one of the things that he said was specifically that data is the next Intel Inside. And I'll let you read the quote here, but essentially it's the way that we used to see organizations get strategic advantage in the market, and Windows is a great example. Windows controlled the APIs for the operating system, the Win32 APIs, and all developers learned how to take advantage of those in the client-server days and build applications on top of them. And because Microsoft managed to create an ecosystem around that and really educated developers on what they needed to do to build apps for their platform, they created a strategic choke point in the market, which created and locked up a tremendous amount of value for their application platform. Well, in the web world, the APIs tend to be a little bit more simpler, and they tend to be open standards implemented by multiple providers and multiple companies. So if the APIs themselves can't be proprietary and you can't use those to create a strategic control point, then the data that you provide access to is the next best thing in creating that strategic control point. Well, let's look at a specific example of that. I would say that most of us that are listening to the call probably at least know what Twitter is. You may not be somebody who actually spends their time on Twitter. I happen to be. But it's a really interesting company because they've essentially created over $1 billion in valuation, 1.5 at this point, around a very simple premise, which is people should be able to put 140-character messages out into a common environment where anybody else who's subscribed to them can see their tweets. And surely there are a lot of banal tweets out there and a lot of noise in terms of the signal-to-noise ratio. But there's a lot of value in Twitter. And it's more than just the business model, it's the data inside. And you'll see that valuation and its increase is in direct proportion to the usage of Twitter as a communication mechanism. And it's the usage of that communication mechanism which is the most important. Because one of the things that you'll see if you look at Twitter and why they've won in this, again, deceptively simple market of simple short messages is because they provided access to the data. That was their Intel Inside. And because they provided access to that data through a set of APIs, anybody who wanted to could tap into that in a variety of shapes and forms and context. So if you look at the current state of the ecosystem around Twitter, you'll see that there are at least 288 different Twitter clients out there. I happen to be a TweetDeck user, and I know a lot of people are, but one of the things you'll notice here from a recent conversation that I had was that the tweets in my friends column and in my mentions column, every single one of them came from a different Twitter client. That's an example of the power that the data will provide to a company when you unlock it. Twitter crosses every different platform, whether it's a mobile device like an iPhone or an Android phone or Windows or Mac or Linux clients or even TVs at this point. We see these clients remixing the core data that Twitter provides in very interesting ways. So there are some tools that will mine a tweet stream and provide you analytics on what's happening. There are other tools that will mine the data and provide trending topics. There are other tools that will tell you how influential you are in the community. These are all things that the Twitter itself as a company really didn't dream up or perfect. But because the access to the data is there, it creates the opportunity for a lot of innovation on top of the core platform. And now what we're seeing is, in large part, that valuation of the company is being driven by some of the value that these different innovative opportunities to mine and provide access to the data provide. So what I'd ask you to do is take something that's a very consumer-focused example, but recast it in what might happen if you could do the exact same thing with your own data with your own company. Let me tell you a similar story, or based on some of the patterns that we have seen out there. The way that Twitter provides access to its APIs are very simple. This particular slide was taken from a document that I wrote about 2 years ago on a set of Web 2.0 patterns. And one of them, the facade, is essentially what we're talking about here, that you use the facade pattern to build a web services gateway on top of your core data, but then essentially create that in a way that multiple channels can take advantage of that exact same capability. And there's by no means anything about this pattern that is limited to the consumer world or the simple world of the Twitters. You can do very complex things with this exact same pattern. Now, if you want to get there, there are some things that you need to understand and know, and we'll be talking a little bit about more of those in a few minutes. Things like REST, representational state transfer. That tends to be one of the ways that we see these APIs being built. There are issues around payloads, and JSON is a very popular format that's used to send data across these APIs. Plain old XML is another way which data gets sent across these simple standardized APIs. But know the pattern, understand it, because it's in this pattern that you unlock the value of your data.
Yes, Jeffrey, and as you mentioned, the service facade is actually one of those ideas that's been around for a number of years. And in fact, it's something that we popularized a lot during the SOA era, which really was the beginning of 2000 up until very recently. Now, SOA, of course, is still a good idea, and there's a lot of good fundamental architectural approaches in there, even though it may be not necessarily the most popular thing now, simply because it's been kind of associated with very, very large and heavily architected projects. But the good ideas there were things like creating a basic service that actually allowed you to get access to your mission-critical data, whether that's the Twitter feed or something like that, or else even just something as simple as your own HR database, which is perhaps mission critical to your organization, but you actually want to somehow get it out there to the people that need it. Today you might be using REST technologies or something like that, as opposed to maybe SOAP technologies that you might have used a few years ago. But the fact is, the idea of a facade is still very, very much alive and very, very important. Over to you.
Absolutely. And I've certainly seen this among our enterprise clients. When I detailed that service facade pattern as a Web 2.0 tactic, one of the clients that I wrote about that was using it was a company called SE2. SE2 provides outsourcing of insurance policies. From a conceptual standpoint, that's about as far as you can get from the consumer-focused world that is Twitter. Certainly not nearly as exciting as 140-character tweets on what Paris Hilton is doing, but the same principles worked very, very well for SE2. They provided access to the data for the policies that they are taking over and administering through, of all things, a web services interface. And then they used that interface to build custom-built UIs that would integrate into the clients that they were actually taking the policies from, that they were administering. And so, from the end user's perspective, at the insurance companies that were now their clients, the information still came directly into their corporate intranets, looked like it always had, and looked like it was part of the company, even though SE2 is now managing that data on its own at a lower cost for the companies. Now, what makes it interesting in SE2's case is the net economic benefit that they found from taking this approach of exposing their data through that service facade pattern. In particular, what they found was that when they would sign up a new client before they took this step, it could take them as much as 6 months to do the integration with their new client's own website. And when they moved to this facade, what they found was that their time to implement went down from about 6 months to 6 weeks. So a pretty dramatic difference in implementation time, and that's become something that is now a core competency and a competitive edge for them as an organization, how rapidly they can outsource the policies and then provide access back to their clients. So I guess what I'd have say then is it's not just about the value that companies like Twitter create out in the Web 2.0 echo chamber. It's also the value that real blue chip companies provide when they start thinking about providing access to data in a standardized way and the value that they unlock. So say you want to do this, and I think there are very good reasons that you should. The question that you would look at is, well, how do I get started? I've got data, I know it has value, and I want to make it accessible, but I'm also kind of concerned about making it accessible. What are the technologies that I should choose and invest in? What sort of best practices should I put in place? What are the potential pitfalls or problems that I might run into? Well, let's take a look at some of those. So, first of all, what I would do is when you start thinking about that facade, you start by thinking about it at the business service level. So yeah, you could go out there and expose 120 different API calls that provide low-level, fine-grained access to all the elements that are in the application that you have today and the objects that are being managed by that application. But in the process, you'll create an API that is so complex and so difficult to understand that really only your internal developers would be able to take advantage of it very easily. What you need to do is start right below the UI layer, so not at the RIA level, Rich Internet Application, but at the business service layer, and think about the conceptual, higher-level logical objects that you want to expose, the services that make sense, and start by exposing those. So protect the folks that might be implementing and using your data from the complexity that you know is there underneath. From there, the next step down would be to then start providing a little bit more access to some of those finer-grained services. So if you happen to be a store or be selling products, you might provide programmatic access to the shopping cart. You might provide programming access to the customer and the customer history so that you could tap in a recommendation engine. From there, you can get even more complex and start providing programmatic access to the workflows, the business processes that you use internally to process that data and to be able to update it. So you might provide direct access to an ordering engine. So a business partner could order products right from your warehouse without having to go through some sort of customer contact with the sales rep. In general, I'd advise you to not necessarily think of providing access to data services in the short run, just because there are some risks. If you provide complete access to the data, somebody could actually strip all the data out of your organization and make it their own. So you might have to worry a little bit about data theft. There are also some challenges if you have data that you want to protect because it's got sensitive fields in it, customer addresses, for example, or customer phone numbers, as well as customer names. So that would be the last step that you would take, and you should feel comfortable really never going beyond the business service or the artifact layer if you don't see that there's additional value in letting your business partners and even external developers get ever closer access to the core crown jewels of your organization. So what are the options when you're going to create these APIs to provide access to your data? Well, there's really three ways to look at it. We already talked a little bit about SOAP, and we mentioned REST. Both of those are great options. SOAP tends to work very well across multiple types of transports, HTTP, but also SMTP and other less commonly seen transports out in the intrawebs. SOAP also does a very good job of working across firewalls and working across proxy servers. It has some very advanced capabilities. So if you wanted to do transactions, if you wanted to make sure that you were doing a multi-phase commit, if you had highly secure data and you wanted to use something like SAML to make sure that only trusted third parties were getting access to that data, SOAP has the standards and the references that allow you to provide for those sort of advanced use cases. There are some problems with SOAP, though. It does tend to be a little bit verbose. The APIs that are used to marshal and unmarshal the data tend to be a little bit heavyweight, so you don't see SOAP endpoints everywhere. You don't see a lot of SOAP endpoints on mobile phones, for example. SOAP doesn't have the best support for notifications like we see with some of the RESTful protocols that make it very easy to push data out to applications. And probably the biggest issue is that the implementations tend to be somewhat inconsistent. There's still some challenges when you're trying to link together web services that have Java endpoints on one end and Microsoft endpoints on another, and being able to parse the WSDLs and generate the right bindings. It's still not as seamless as it should be, in my opinion. REST, on the other hand, tends to be very simple, which makes it very popular with developers. It only requires a browser and an HTTP stack, so it's very, very easy to consume it across a wide variety of endpoints. And it tends to work very, very well with the current design pattern that we see used to build a lot of websites. That design pattern being one which uses asynchronous JavaScript and XML, or even uses a Flash container or a Silverlight container, and does a lot more processing on the client side and minimizes the amount of back and forth communication that is done with HTTP requests, so an asynchronous style of architecture. There are some challenges with REST as well, though. It is a pattern. It's not a standard, so there's no one way to do REST necessarily, although there are some popular formats that are supported from a payload perspective. Unlike SOAP, it's difficult to implement a RESTful API and guarantee a certain quality of service just because of the nature of HTTP itself. And fundamentally, REST works best when you're designing an API around a resource-based model. It's not really to do APIs like you would if you were using RPC calls. So you need to think about the types of payloads that you're sending back and forth. Now, I've put a third option on here. It's something that's a little bit further out, but we are already starting to see some very interesting sample implementations where applications are talking between web server and client using WebSockets technology. WebSockets is one of a set of APIs which is loosely part of the confederacy of HTML5 standards. WebSockets are bidirectional and full duplex. So think of them as a TCP/IP socket in the browser. And because they're structured that way, they allow full duplex communication in both directions simultaneously. Much like SOAP and REST, they are firewall and proxy friendly, but they are very efficient and have very low latency. So if you wanted to open up a binary communication channel, a WebSocket would definitely be the way to do that and do it with a very low overhead. The problem with WebSockets right now is because they are an emerging standard and part of that HTML5 movement, they're not supported in all browsers that you're going to see right now, most notably not in any version of Internet Explorer before IE9. There's still very limited support on the server side in terms of servers that actually natively support WebSockets and the specification out of the box. And the standard, because it is still new, is still evolving. We need to see common implementations which can work and talk to each other. And right now, we're not really at that point where we can say that WebSockets are a consistently implemented technology across multiple web servers and across multiple browsers.
Yeah, I have a lot of customers actually that ask me about this, and one of the big questions that comes up all the time is, which one should I use? Should I use SOAP? Should I use REST? Should I be looking at WebSockets? And I tend to kind of enigmatically reply, well, ask the application what it wants to be, because really your fundamental requirements that the application is trying to meet should define what technology you should use. The big problem with any of these technologies is it becomes a bit of a religious thing. There's people that we like to call them Restafarians, which jump so much on the REST idea that they're convinced that it's the one true way of doing all distributed communications. And the truth is, it is a very, very good approach, and I highly advocate it. And in fact, it makes a tremendous amount of sense out there on any kind of web-facing app where you can do point-to-point communications. But the thing is that there are other kinds of apps which need, let's say, true reliability in their messaging, guaranteed one-time delivery, these kinds of quality of service aspects, which obviously are not things that we associate with the web in any way, make the decision to go to something like SOAP much more palatable and that. And so really the important thing to walk away from this is the idea that different technologies have different characteristics and attributes, and you should sort of step back a little ways and really let that decide. Look hard at your requirements and figure out what makes the most sense. Don't just choose one because you think it's the up-and-coming thing or you happen to like it or you've done work in it. Choose the one that makes the most sense to you.
Yeah, I think that's a great point. To me, the term fit to purpose very much comes to mind here, and different applications are going to require different technologies. So I absolutely agree with you. I will say, however, though, when we look at web APIs and what's out there right now, I think REST does have the edge among the development professionals that I talk to. The reason for that is because it is simple, and a lot of times it seems the simplest, most easy to grok technologies are the ones that win, and it makes sense. Developers are always constantly juggling 10 different balls and trying to keep them all in the air, and the last thing that they want is a more complex solution than what will get the job done. So developers do like REST. The use of HTTP maximizes the reach of RESTful APIs. They can be accessed from a lot more places because all you essentially need is the HTTP implementation on the other end of the endpoint. It also tends to work very, very well when you're designing APIs that have lighter weight payloads, and especially those resource-based payloads where you're exchanging chunks of documents. And a serialized object can look an awful lot like a resource in document form. As I mentioned earlier, we see this combination of RESTful API with RIA technology, whether it be jQuery or GWT or even something like Flash, because a lot of the RIA frameworks have implemented a RESTful communication layer. That's also tipped the edge in the favor of a RESTful style for the apps that we're seeing implemented. That's also very true on the server side, as we see more and more Java developers, for example, using Spring. The Spring guys have really kind of looked at supporting a RESTful architecture as part of their communications protocol. The Ruby on Rails folks, and we all know that Ruby is the rage with a lot of folks out there, outside the firewall, essentially implement the RESTful approach and look at that as the best solution to enable API-based communication. And I guess the last thing that I would add is that the sites that developers tend to be most interested in integrating with have also tended to do more with REST and see more pickup in RESTful APIs as compared to other options like SOAP.
Yeah, there's a lot to be said for actually developing with a web browser. It just makes things very, very easy. And I think if you look at a case study like Amazon Web Services, you really see that bias on the part of developers in the community with REST. AWS, for instance, when they first came out with parallel implementations of both SOAP and REST for both of their APIs. And the truth is the community has spoken very, very loudly and in terms of what they want to use. And REST is the great winner there, although there still are SOAP APIs for a lot of those functions. Really, it's down to 95% REST and maybe 5% SOAP for a lot of people that have the tooling already in place. So if it's there, if it's working well for you, that's definitely the way to go.
Yeah, and we certainly see that if we actually look at the sites that developers are most interested in working with or using. This is just a quick profile of the top 10 or top 12 most popular websites in the U.S. by traffic as reported by Alexa. And when you look at A, whether or not they have APIs, and then B, if they do have APIs, what sort of APIs they have, what you see is, some of the sites have both SOAP APIs and REST APIs, and you gave the example of Amazon, who's number 5 on this list. But by and large, there's a lot more REST going on than there is SOAP. And where there's only one format being supported, one or the other, it tends to be a RESTful implementation. That said, there's a little bit more SOAP than there was if I had looked at this list maybe 2 or 3 years ago. So folks are giving developers more than one choice, and a lot of it depends on, again, the point that you made earlier, what do you want the application to be? Some of the APIs, it makes sense to provide a heavier weight API because they're really designed for merchant integration into Amazon, as an example, where transactional confirmation is something that's viewed as valuable in that particular case. In the case of Microsoft, Microsoft was an early implementer of SOAP. They started with SOAP and did that primarily, but you'll now see, if you look at numbers 10 and 11 on this list, they've also embraced support for REST and have added those capabilities as well. So they're no longer the only folks on the list that support SOAP and nothing else. So how do you build this in if you've already made some pretty significant investments in SOA? The good news is that I wouldn't look at the types of APIs that we're talking about today as fundamentally different than any of the existing SOA investments that you've made, especially ones that are SOAP-based. What I would say is that you need to extend your existing services model, and this is one we use at Forrester. Yours might look a little bit different, but I think this is a good one for the canonical argument. What you need to do is you need to take it and extend it so that you can provide RESTful service intermediation for any core services that you have today. You need to extend it so that you can provide support for lightweight app platforms, things like Ruby or and the Rails framework or the Spring framework or the Zen framework that really depend on a RESTful style communication architecture. Once you've got that RESTful layer and even support protocol conversion between services that might have originally been designed in SOAP but that you also want to expose in REST, you can then provide access to a wide variety of endpoints, and it really gives you a lot more flexibility. So let's talk about some of the best practices involved in creating those APIs. I would tell you there are 7 questions that you need to answer as you're looking to decide how to proceed with an API-based strategy to provide access to your data. You need to look at your AAA strategy, so access, authentication, and authorization. You need to figure out how you're going to manage access to the APIs and the qualities of service that you're going to provide for them. How are you going to protect your APIs from a security perspective? Will you support multiple protocols? Are you just going to do REST, or are you just going to do SOAP, or are you going to do a mix of both and also be prepared for WebSockets? how do you manage the life cycle of the APIs? And by that I mean, one of the issues when you provide a service out there is you don't necessarily get real good data on who's using the service and how much and how critical that's become to their business. If you just change it, change a protocol, change an argument, make it non-conforming, and you don't warn people, you run the risk of breaking all your existing customers out there. So you may need to have multiple versions of a service. You may need to advertise that you're going to be retiring the service and providing for some life cycle management that doesn't create a lot of shock and pain with the folks that are now depending on you to provide them data that helps them make their living. Two other things that you need to think about: what sort of deployment options, where are you going to make the APIs available, where are you going to manage the process of providing access, and then what sort of analytics and metrics are you interested in capturing.
And actually, here's something to note about all of these, is that really when you look at them, they're the kinds of things that you have to generally implement on every single service or every single API. These are kind of common attributes that are going to come up again and again and again. And so if you've got a lot of different implementations, let's say I've got a Rails server over here, and I've got some Java kicking around, and I've got some .NET even in my environment, which in a large enterprise is not uncommon, of course. You really have to go through and try to implement every one of these on a case-by-case basis. So what would be better is if you could really start to tease this out. In other words, decouple these attributes and start to pull them out of the actual code or the actual low-level infrastructure like your application server or what have you, and try to get reuse. Try to share things amongst all of them, because every one of these, and in particular the things that have to do about security, really are things that will come up again and again and benefit from a centralized approach, because really the soul of good security is consistency again and again. So more on that in a minute. Jeffrey, back to you.
Right. Thank you. So the first two of these, just some recommendations. One of the things that we would say is that you should really look to generate unique keys for each partner, each developer that is going to be signing up to access your APIs. That just gives you a lot of control in knowing who's doing what and when they're doing it and how they're doing it. There are a lot of different algorithms out there that will let you generate unique keys. One of the things that you need to look at is, do you want a built-in algorithm to do that, or do you want the flexibility to plug your own algorithms in? I think the latter is the best, because you can kind of keep up with the times as we get more sophisticated algorithms, or as we find challenges with existing algorithms. I wouldn't try to spend a lot of time on providing robust, consistent authentication. What you really want is a one-time authentication that then provides some sort of authorization capability. None of us as users like to always have to log in every single time we access an application. And when you've got applications that are accessing data through an API, that exact same principle is true. So in particular, if you can implement a token-based authentication strategy, it gives the users a lot of convenience because they don't have to constantly re-authenticate, and it also gives your applications and your APIs a way to delegate specific capabilities of access and do that via policy, and it just makes things a lot easier, a lot more user-friendly, but a lot more flexible on your part. The other thing you can do is you can group those tokens into different classes of access. So you might have a generic token which allows a certain level of complete access, maybe at a metered rate. If you think of Twitter, if you're using it through the API, you get a certain amount of refreshes per hour that your applications can take advantage of. You can issue better, larger, more powerful tokens for your business partners to provide them higher level use or guaranteed qualities of service. So if your server farm is under load and you need to start restricting access, you can start with the generic users and then start to impair the services of the higher level users as a last resort. You can also provide access by function using these tokens. So you might have a special set of tokens that would provide access to the workflow layer of your APIs, while others would just provide access to that business facade layer. So if you've got APIs that you only want your most trusted business partners to have access to, you can use policy and tokens to implement that.
Yeah, it's always about APIs, it's always about identity, isn't it? Regardless of what applications we're building or what we're doing, a good, solid sense of who's using what is actually really, really critical. And the thing that makes it complicated in a lot of API environments is really that you want to leverage existing identity. You don't want to create yet another island of identity. This is one of the problems that a lot of the software as a service vendors are ending up with, is that they're creating these wonderful websites and things like that give us tremendous value, but they're also creating a new island of identity. You create a new account up there. And you know what? The last thing I need is yet another Scott Morrison.
Yeah, I'm thinking, come on, what's the problem with me having to have my full page of all my logins that I have?
Yeah, that's exactly it. So here's the thing to really look for in this is as you're beginning to create APIs and that, look not only to integrating with your own existing identity and access management systems, because everybody's got these already. Everybody already has LDAP or Active Directory or even something like Integrity out there. People have those, and so you need to be able to integrate with that effectively. But you also need to really support things like federation, which can be expressed in a lot of different kinds of security tokens, whether it's through Kerberos or through SAML, or even using things like OAuth, which give you a kind of a piecemeal approach to federation. Think about that up front. It's not an easy problem, but there are tools that actually help you along with this.
Great. When we look more at access management and quality of service, I guess the biggest thing that I would encourage you to think about is how do you provide throttling of your APIs and do that in as flexible a way as possible. So you could, for example, throttle by providing global access or access to individual classes, access to individual users or a subset of users. If you were looking at providing regional access to specific client data or patient data, for example, you could provide access to specific endpoints or versions of the API. If you wanted to force people to migrate off of one version of an API into another, you could do that with an access policy. You may also want to limit access via a time-based metric, so calls per hour or calls per day or calls per week or month, and say, well, if you want a higher throughput rate, then, let's talk about a paid level of service access, so you start to monetize your APIs. You also want to be able to implement throttling policies dynamically so that, again, if your servers are under load, if you need to shift who can access what and how quickly, you've got that capability to do it on the fly. It's really the policy-based throttling that becomes extremely important. From a security perspective, the basics of a web application apply equally well to APIs. You want to use transport over SSL or TLS wherever possible to improve the security of the data while it's in the transmission phase. You want to, if possible, implement your APIs on a sub-site so that if that site gets compromised, it doesn't necessarily compromise your main site. You want to be able to use things like IP whitelisting or blacklisting to help reduce attacks from known domains that have folks that are going to try to probe your APIs and see what kind of access they can get through them. You definitely want to load balance your endpoints by geography to reduce the latency of access to data. And then, again, just basic blocking and tackling on the inside of your APIs when you're looking at the data that's coming in through the requests. You need to do your basics like implementing a positive filtering algorithm to prevent things like hijacking attacks and that sort of thing. This is especially important if you happen to be using a REST-based API and you're looking at JSON or something like that as a payload format. You can have stuff sneak by if you're not specifically looking at what's coming in.
And what we're seeing now really is this move towards a greater concept of what policy is about. I mean, if you say policy to a lot of people, they just think in terms of AAA, authentication, authorization, and audit. But really, policy is a way of articulating all of those things, plus the things that you've mentioned here, things like SLA, things like the confidentiality of your transmissions, things like how you load balance. And what really makes sense is a single place where you could administer that policy and enforce that policy. And that's exactly what we're leading up towards.
From a protocol perspective, my advice is don't put all your eggs in one basket, because there will be times when, SOAP might be a better approach, and there are certainly times when REST is going to be a better approach. And of course, the question is, well, which REST are you going to implement? What protocols, what payloads are you going to support? And then I don't think that you want to, completely ignore the long-term trend toward WebSockets as an additional capability here. So in an ideal world, what you want to do is you want to define the information that you need to provide access to, the data, and then you want to generate the access to that data programmatically and as as reliably as possible. You want to make it easier to keep all those different protocols up to date as well. You really want to be able to support multiple versions. You want to publish the support policies around those individual versions. It's very important to communicate when an API is going to be deprecated. And then you would really like to be able to use a version-specific endpoint so that, if I'm always wanting to use a specific version of the service, I could, perhaps say I'm pointing at version 3 of that, or, even use a label similar to what we see in SCM, where I can say I always want to point my application at the main latest equivalent of the service APIs, so that if things update dynamically, I'm prepared for that, even if I know it might break. But I always want to have the most up-to-date APIs and information coming into my my third-party application. Finally, deployment and measurement. What you really need to look at is, how am I going to do this, and how am I going to get up to speed very, very quickly? There are a variety of different approaches. There are some capabilities out there where you can essentially put an API out in a hosted world, and that can be very, very helpful when you have a simple, quick implementation that you need to get out as quickly as possible. There are also solutions that you can install on top of your existing hardware that'll let you use a standardized infrastructure, and they tend to be very good when you have a medium level of need and want to provide access to maybe a few partners and customers. You're not sure whether or not the APIs and the data you have are really going to be valuable, whether they're going to create significant new demand and opportunity. But for those folks that know that their APIs are going to create a tremendous amount of value, and they're going to see a really high demand for access to data, the appliance capability is something that's very interesting, because you can use hardware to do significant optimization of the marshaling and unmarshaling of the data that's going through the APIs. You can dramatically accelerate the capabilities of the API to provide that access to data. From a measurement standpoint, you really want to make sure that you're providing positive data that allows you to understand who's using your APIs and how they're using it. So some things that I think are very useful to collect: who's using what methods, are there pieces of your API that you can prune because nobody's really using them, how many developers are using them, what versions they're using, and how quickly developers tend to upgrade from one version to the next, what the geographic distribution of that access is. Is it all in the United States? Is it balanced across the U.S. and Europe? Or are there a lot coming from Asia? You also want to be able to detect irregular usage patterns, because those might be the sign of a pending attack on your API, somebody probing it, trying to find out what sort of data they might be able to get access to that they're not really authorized to have.
And if you're sitting in front of the API, you're effectively that policy enforcement layer. You're in a very, very privileged position, really, because you can see all of the traffic. You're usually in an encryption-decryption point, so you actually get visibility into the actual payload and content, which can suddenly give you tremendous information about audit and things like that, which you can use again in a compliance manner or something like that. So this is a very important place to be, and you should really be leveraging that.
So some final recommendations. Whether it's Twitter or it's SE2, think about the value of information that you already have, that you're collecting on a daily basis, and how that information, if you provided access to your partners and even an end community, could create additional value for your organization. Use the APIs that you would build on top of that data to develop lower cost channels so that you can service your customers more inexpensively than ever. You can service them directly through the web and not through higher cost channels like person to person or over the phone. You don't have to throw out your existing SOA strategy. You should just extend it to make sure that you're thinking about publicly consumable APIs. It's not just a technical exercise. You need to think about it from a business perspective. You need to design your APIs so that they're easy to implement, easy to use. You need to think about how much access you're going to provide and how you're going to meter that. I would start small and quick. It's better to experiment, learn, and then react to what you've learned and keep moving forward than to try to plan some big initiative and not get something out there quickly, because you're probably not going to get it right the first time. And then think twice before you reinvent the wheel. Don't necessarily go out there and try to implement all the protocols yourself. Do everything manually. You can absolutely make that work and do that and make that happen. But I would argue that it's probably not your core competency. And since there are tools and capabilities out there that can help you do this very, very fast, I think it makes sense to take a look at some of those and see how they might be able to help you get something out very, very quickly. So with that, let me pass things over to Scott.
Great, thank you, Jeffrey. Well, listen, that was really, really interesting, and I think you did an excellent job of really laying out what those future requirements are that we're actually going to need. Now, what I'm going to do is take up on that and kind of show you some real technology that can actually solve these problems right now, and that's exactly what Layer 7 is doing with its CloudSpan products. Now, CloudSpan is a new product line specifically from Layer 7 that builds up on its award-winning SecureSpan line. SecureSpan was technology that's been evolving over about 8 years, and it's really there to actually protect and manage any kind of services in your network. CloudSpan is a version of this that builds on all of those capabilities, but is very, very specifically built to help you manage APIs effectively and monetize those APIs so that you can get them out rapidly, you can do it securely, and you can have the visibility into who's using what and when. Now, the way we do that is with a CloudSpan security gateway, and this gateway can either be a physical device, so quite literally a 1U rack mount device that you plug into your network, usually in a DMZ, but it can actually show up just about anywhere in your network, depending on what your needs are and what your topology is. And what it does is it gives you a place to author policy, to create policy, and to put it into action. And remember, policy for us is much more than just the simple AAA. It's much more than authentication, authorization, and audit. It actually encompasses all of these declarative characteristics that you can pull out of your APIs and manage centrally in one location. All of those things that Jeffrey so carefully went through and talked about, whether it's recording information about who's accessing what and when, dealing with the authentication, the authorization, and the audit, but then also dealing with SLAs, doing traffic shaping, doing load balancing between different implementations of servers, making very intelligent decisions based on load characteristics and who you are as a user as to where your request will actually be routed. If you're, let's say, a very, very good customer, I'll probably want to send you to the fastest server I've got. If you're, an occasional customer, I'll probably send you to one of the slower servers because I want to save my really, really fast response times for the people that are making me a lot of money. These kinds of business decisions can actually be enacted in one of these gateways. Now, I started by talking about this in terms of something that's a very hardware-based gateway. But you know what? We can also do virtualized gateways, which I think are one of the big things that we're going to see more and more of in the appliance world. I think a lot of fundamental infrastructure, whether it's basic routers or DNS servers or firewalls or security gateways like CloudSpan, are going to be more and more deployed as virtualized devices in racks and racks of generalized equipment running hypervisors. We've been doing this for years here at Layer 7. In fact, I run the whole security gateway on my MacBook all the time, and it has all the same characteristics. It's functionally exactly the same as one of our hardware gateways. So we have these in production, and we can mix and match them, hardware and virtualized devices. The only difference tends to be performance characteristics. Obviously, the hardware has some very specialized equipment in it to do accelerated processing of different kinds of transactions, like XML-based transactions, whether they're REST, SOAP, or what have you. Now, the next thing to consider in this is the whole policy language, how you effectively articulate what you're going to do to one of those transactions. The way we've done this at Layer 7 is we've created a policy builder that actually allows you to drag and drop basic assertions. Basic assertions are kind of like, little snippets of code, if you will, and you can kind of create an algorithm to solve problems. What I don't want to give people is a simple point and click, check off this for SSL, check off this for basic security. I'd rather give them the fundamental building blocks, those components, so they can really solve their basic problems. Where it really shines is if you have an interesting integration problem. And remember, integration these days in the API world isn't just about integrating data and applications. It's also about integrating security models that may be radically different between a sender and a receiver of information. These are the kinds of things that can be very, very difficult to deal with unless you've got something like the policy language within CloudSpan, which has all the components you need to mix and match different transports, mix and match different security models, and tie the whole thing together into a secure, rigorous and robust, comprehensive approach to dealing with all of your different APIs. And now finally, CloudSpan is really also built so that you can effectively monetize your APIs, get them out to a whole range of different potential users. And with that, it means a whole range of different kinds of access points. Remember, a lot of what the cloud is about and a lot of what APIs are about is trying to open up across the internet to a wide variety of platforms, whether it's your iPhone or your iPad or your MacBook, or it doesn't matter what it is. Every one of these systems can actually get access to an API because it's based on a sort of a consistent approach using either REST or SOAP or what have you. And all of that can very effectively be managed through the whole CloudSpan model. So with that, I'd like to thank Jeffrey for joining me on this. We've had a very, very interesting discussion here. And if you want to follow up or talk to either of us, by all means, get in touch with us. Again, my name is Scott Morrison, and I'm the CTO of Layer 7. You can get in touch with me at smorrison@layer7tech.com. And by all means, drop me a line. I'm always interested in talking about new ideas, new technologies, and how we might be able to help you out. So thanks again for joining us, and I hope the rest of your day goes well.